Imagine this. You're sitting in a car, but there's no driver. The car smoothly navigates through traffic, makes quick decisions, and keeps you safe. Sounds like a scene from a sci-fi movie, right? But this is happening right now, thanks to deep learning. Or picture this. You finish watching a show on Netflix, and it instantly suggests another one that you end up loving. It's almost like Netflix can read your mind. But no, it's deep learning at work, understanding your preferences and making smart recommendations. These incredible technologies are powered by deep learning, a fascinating branch of artificial intelligence. Think of it as a digital brain, helping machines make sense of data in ways that mimic human thinking. It's the magic behind many of the smart tools we use every day. Deep learning is revolutionizing our world. From healthcare to finance, entertainment to transportation, its applications are vast. Imagine a future where diseases are detected early, fraud is caught instantly, and everyone has access to personalized education. By learning from massive amounts of data, deep learning enables machines to make smarter decisions. It identifies patterns and makes predictions, often outperforming traditional methods. This ability to learn and improve makes deep learning incredibly powerful. In this guide, we'll break down deep learning into simple, easy-to-understand concepts. Whether you're a tech enthusiast or just curious about AI, you'll find something fascinating here. We'll explore its core principles, diverse applications, challenges, and future trends. From the workings of neural networks to the ethical dilemmas of AI, we'll cover it all. Plus, we'll dive into the latest research and what's on the horizon for deep learning. Get ready to embark on an exciting journey into the world of deep learning. This adventure will deepen your understanding of AI and spark your imagination about the endless possibilities it offers. So let's dive in and uncover the wonders of deep learning together. Imagine a world where machines can think and learn like humans. That's the magic of neural networks. Inspired by the intricate workings of our own brains, these networks mimic how we process information. Picture layers of artificial neurons, each one learning and passing on information just like the neurons in our brain. These neurons are connected by pathways, and each connection has a weight. The weight determines the strength of the connection, much like how strong or weak a signal is in our brain. As the network learns, it adjusts these weights, fine-tuning its ability to understand and predict. This continuous learning process allows neural networks to recognize patterns and relationships in data, unlocking endless possibilities. Imagine you're building a complex machine, one that can think and learn like a human. To do this, you need to understand its main parts, the building blocks that make it all possible. These components are what enable machines to perform tasks that usually require human intelligence. By diving into these parts, we can uncover the magic behind deep learning and see why it's so transformative. One of the most fascinating parts is the activation function. Think of it as a gatekeeper, a mathematical equation that decides what information gets through the neural network. It introduces non-linearity, allowing the network to learn intricate patterns. Without it, the network would be too simplistic to grasp the complexities of real-world data. This non-linearity is what enables the network to understand and learn from complex data, like recognizing faces in photos or interpreting human language. Activation functions are the secret sauce that helps the network make sense of the data, leading to smarter predictions. Next, we have the loss function. Picture it as a scorekeeper, measuring how close the network's predictions are to the actual results. It guides the network in its learning journey by showing how well it's performing. By minimizing the loss, the network becomes better at its tasks. The loss function highlights the gap between the network's guesses and the real answers. The network's mission is to close this gap through training. By tweaking its settings, the network learns to make more accurate predictions. The ultimate goal is to minimize this loss. Achieving a lower loss means the network performs well not just on the training data but also on new, unseen data. This makes the model valuable in real-world applications. Enter backpropagation, the hero of our story. This method adjusts the network's weights based on the loss, fine-tuning the network to reduce errors. By sending the error backward, backpropagation helps each layer learn to correct its mistakes. It's like a feedback loop, continuously helping the network learn from its errors. This ongoing process of learning and adjusting makes the network smarter over time, leading to more accurate and reliable results. And that's the magic of deep learning's building blocks. Imagine a world where deep learning is revolutionizing everything around us. In healthcare, it's diagnosing diseases faster than ever, and in finance, it's predicting market trends with incredible accuracy. Picture this: computers that can see and understand images just like we do. From recognizing faces to detecting emotions, the possibilities are endless. Think about self-driving cars navigating busy streets, medical scans that catch diseases early, and security systems that keep us safe, all powered by deep learning. And it doesn't stop there. Deep learning is making it possible for computers to understand and communicate with us, breaking down language barriers and enhancing human-machine interaction. This technology has given rise to chatbots that assist us daily, virtual assistants that make our lives easier, and translation tools that bring the world closer together. Welcome to Section 5. The importance of training data. Imagine trying to teach a child to recognize animals. You'd need lots of pictures, right? Deep learning is similar. It needs tons of data to learn effectively. The better the data, the smarter the model becomes. It's like giving the child clearer, more detailed pictures. Data scientists are like the diligent teachers, tirelessly gathering and cleaning data to ensure the model learns correctly. For instance, to train a model to recognize cats, we need a treasure trove of labeled cat images. The more the better. Welcome to Section 6, where we dive into the hurdles of deep learning. Deep learning is a game changer, but it's not without its obstacles. Imagine needing mountains of labeled data just to get started. Gathering and labeling all that data, it's a time-consuming and costly affair. Then there's overfitting, where your model aces the training data but flunks in the real world. And let's not forget the mystery of how these models make decisions. Often, deep learning models are like black boxes, leaving us guessing about their inner workings. Section 7. The future landscape of deep learning. Imagine a world where deep learning is constantly evolving, pushing the boundaries of what's possible. In labs around the globe, scientists are tirelessly working to enhance deep learning, discovering new techniques every day. One of the most thrilling advancements is in reinforcement learning, where computers learn by experimenting and adapting. This technology is revolutionizing fields like robotics, gaming, and even self-driving cars. Another fascinating trend is explainable AI, which aims to make the workings of deep learning more transparent and understandable. Welcome to Section 8, Deep Learning and Ethics, a Responsible Approach. Imagine you're building a powerful tool, but you need to ensure it doesn't harm anyone. That's where ethics come in. Think about bias in data. It can lead to unfair outcomes affecting real lives. And then there's privacy. Using personal data means we have to be extra careful. Our goal? To create deep learning systems that are fair, transparent, and responsible. Welcome to the final chapter. Embracing the deep learning revolution. Imagine a world where machines think like humans, processing data and making decisions. This is the magic of deep learning. From healthcare to finance, transportation to entertainment, deep learning is not just a tool, it's a game changer, transforming our everyday lives. Picture self-driving cars cruising down the highway, reducing accidents and easing traffic. Envision doctors using AI to tailor treatments, making healthcare more precise and effective. Even our daily interactions with virtual assistants and recommendation systems are powered by deep learning, making our lives smoother and more connected. As we dive deeper into the world of deep learning, curiosity and responsibility become our guiding stars. Researchers are constantly uncovering new possibilities, but we must also address crucial issues like data privacy, fairness, and the impact on jobs. Education and collaboration are essential to ensure that deep learning benefits everyone. Let's embrace the deep learning revolution and harness its power to build a better world. By fostering innovation and inclusivity, we can ensure that deep learning serves everyone. Together, we can create a future where technology and humanity work hand in hand, enhancing life for all. The deep learning revolution is here, and it's up to us to steer it towards a brighter, more inclusive tomorrow. Don't forget to subscribe, like, comment, and share this video. Join us in spreading the word about the deep learning revolution.